This video describes HPLC AutoLAB, automating method development and purification in a fast-paced lab, improving performance with PDR software, hardware, procedures, and support. My name is Gary Yannick. My email is gwyannik@pdr-separations.com. Typical AutoLAB installation. Add PDR hardware, eluent mixers and column selectors to method development systems, injector collectors to purification systems. Install AutoMDS and AutoPREP softwares onto new PCs. Write new methods and new sequences, teach new procedures, and train staff. After a brief learning period, throughput increases 5 to 10-fold thanks to efficient processing and near continuous running. Lab space is reduced to 70 to 90% of previous because fewer systems are needed. Lab staff is reduced to 50 to 80% of previous. And thanks to automation and efficient procedures, remaining staff is able to spend more time on other activities. Result is more productivity in a smaller and happier lab, doing more with less. Typical procedure. Put sample in autosampler, select appropriate sequence, and run. Multiple runs are often queued for nights and weekends. When sequence finishes, data processing tool automatically displays chromatograms that match your filter settings. Convert selected methods to isocratic using our gradient plot, then optimize eluent composition and loading. Scale up and compare optimized methods in PREP Predictor. Set up purification system with scaled settings and make a test injection. Visually optimize detection and collection settings using Recalculate to quickly rerun detector data using new detection and collection settings. Start purification run and observe first few injections. All settings can be changed while running. Consider increasing injection volume and reducing cycle time when system equilibrates. Method optimization key points. Recognize the largest separation is not always the best method. Appreciate elution order. Early peaks are more concentrated. Remember, injection mass is often limited by solubility in the maximum injection volume of the column. Consider recovery from the eluent. Do solvents and additives evaporate? Use PREP Predictor to make best method decisions. Method optimization. Convert gradient methods to isocratic using our gradient plot to estimate eluent composition at elution and optimize. If peaks are too far apart at maximum loading volume, adjust eluent to reduce separation. Too much separation increases injection cycle time and reduces productivity. Stacked injection example, showing reasonably close peak spacing. Load until impurities affect peak collection purity. Here is an example of closely stacked collection using a polarimeter. Closely spaced peaks result in high productivity. Less than 1/3 of eluent is going to waste in this example. Notice into-bottle injections are automatically collected correctly thanks to the adaptive capabilities of AutoPREP. Here is a method development plumbing diagram. PDR adds AutoMDS software, eluent mixers, and column selectors. Now there are many bottles and many columns under full control. With proper planning, it should not be necessary to manually change columns or solvents. Just select or program what you want. Manually changing anything in an HPLC implies downtime and increases the risk of leaks and more downtime. An optimized system can operate 24/7 for many years with minimal attention. AutoMDS. AutoMDS is an automated method development system used to develop separation methods for subsequent analysis and purification. Here's our software showing 2D and 3D plots at multiple wavelengths. Here is a hardware system using Agilent Analytical HPLC fitted with PDR mixer, selector, and digital advanced laser polarimeter. Master sequence libraries. PDR builds intelligent master sequence libraries after carefully considering analytes, columns, eluents, purification flow rates, solubilities, additives, equilibrations, miscibility, column care and cleaning. Here is a chiral library of master sequences as an example. AutoMDS and AutoPREP softwares. AutoMDS and AutoPREP softwares have the same user interface, regardless of hardware, and many common and convenient features. Methods, cycles, and sequences only contain chromatographic parameters that PDR drivers translate into hardware-specific commands, making method transfer easy, even if hardware is different. All parameters can be changed while running. Recalculate reruns detector data, show detection and collection with new settings, making optimization quick and visual without more injections. Method and sequence editors use a simple spreadsheet format, making it easy to build, edit, and monitor methods, cycles, and sequences. Real-time 2D and 3D plots and calculations. 2D and 3D plots show data in real time continuously. All PDR softwares detect and calculate in real time and exhibit dynamic adaptability. Data processing tool is very useful. You can set minimum area, time interval, number of peaks equal to, greater than, or less than, the peak equality percentage, minimum retention. If you're doing a chiral separation, set the number of peaks equal to 2 and the peak equality equal to plus and minus 10%, for example. Chromatograms load automatically. Filter settings are applied and selected chromatograms appear. Repeats runtime status display. Shows waiting, active, remaining, and done status of methods, cycles, and sequences in AutoPREP and AutoMDS, making it easy to schedule work efficiently, knowing when results will be ready and the next job can begin. Scaling from analytical to purification. The objective is to accurately predict purification parameters so methods can be pragmatically compared and purification systems can be set up quickly. A linear example: if all columns are 5-micron particle by 250 millimeter length, then scaling is linear by column area. For example, a 4.6 millimeter diameter analytical column and a 21.2 millimeter diameter purification column would scale by 21.24. And here is the math. Best to estimate preferred flow rates for purification columns and eluents, often limited by pressure, then scale down to analytical flows so elution times are the same for method development and prep. Then the analytical flow would equal the purification flow divided by 21.24 in this example, and the purification load, or the injected mass, should equal the analytical load times 21.24 in this example. If particle size or column length are different, scaling is not linear, but still predictable using online tools. The PDR-Prep predictor. AutoPREP systems and procedures emphasize accurate predictability and robust consistency. Predictor shows total time, total eluent collected and to be evaporated, and the productivity of the method with respect to the column packing material. Here's a diagram of a purification system. PDR adds AutoPREP software, injector collectors. Now there are many collection ports and methods can be changed while running. AutoPREP. AutoPREP purification systems can be installed at any scale and are designed to run unattended. Here is a picture of the software showing stacked injections, and here is a picture of a hardware system using Agilent semi-prep HPLC and a PDR injector collector. Here's a larger scale AutoPREP purification system using SD1 pumps and Knauer UV. Notice in this case the injector collector is fitted with larger loop and larger valves to accommodate the larger flow. AutoPREP controls any size solenoid and pneumatic valves, additional pumps for injections, etc., external events. Experienced PDR staff. Gary Yannick is president, experienced with management, sales and marketing, production, electronics, mechanics, lasers, physics, etc. Nezmi Bugdasi is a world-class mathematician, experienced with physics, simulations, algorithms, and software. Soidan Kavral is a very creative software programmer, experienced with robust control of complex systems using complicated algorithms. Ken Burgess is an IT master, experienced with all things internet, computers, peripherals, and software. Achievement history. We've been the best of the best for more than 25 years. In 1996, we patented and started shipping the advanced laser polarimeter. In 2000, we started shipping AutoMDS and AutoPREP hardware software systems. In 2001, we started using SFC in method development and purification. In 2006, we installed an explosion-proof polarimeter and UV detector on a production scale SMB to deconvolve chiral separations in real time. In 2016, we started shipping real-time spectral deconvolution with FiberDad spectrometers. In 2021, we started shipping digital advanced laser polarimeters. Science, math, engineering, software applied with creativity and robustness. Advanced hardware, software solutions to automate separation, analysis, and purification, especially for big pharma. Return on investment. PDR usually reconfigures existing pumps, detectors, and autosamplers with PDR hardware and software. Per system cost of PDR hardware, software, installation, training, and support is less than half the cost of a new HPLC that would require more space, more staff, and less productivity. Since throughput increases by multiples, while systems, space, and staff are reduced, ROI is very high. Upgrading to PDR AutoMDS or AutoPREP is cost effective. Do more with less for less money. When you are ready to improve and accelerate separation, analysis, and purification, please contact me directly. GWYANIK@PDR-Separations.com. Thank you.